Hello everyone, welcome back to the stream. I've got some fun stuff to do. Basically, the challenge for today's stream is to figure out an algorithm for placing enemy cards on a grid. So we want the AI boards to be sensible and also to be strong. We want, if there's going to be a card that provides bonuses to other cards on an enemy board, we want that card to actually provide its bonuses and not be placed in a nonsensical position. So I've been trying to figure out what a good approach for that is. I think I found something. The AI recommended an algorithm that I'm going to try, so we're going to see how that works. But before I get into it, Gunforged is available for sale, so if you want to support my work, you can purchase that. It's $8.99. You can also wait for a sale if you want to add it to your wish list. Very much appreciate that. Also, I have my Udemy courses available for sale. Those will teach you how to build a complete game in the Godot engine, and that's also a great way of supporting me. So check out the links in the description below. All the ways you can support me are there. Okay, so let me show you what I have right now, and then I'll go over my understanding of this algorithm that we're going to use, and then I'm going to start working on it. So this is kind of what we want over here. So this is an enemy board, and this is my board as a player here. And the enemy board here has an incense item, which is interesting because incense reduces the remaining turns of adjacent minion cards by 1. However, you'll notice that it's not been placed next to a minion card. This is a minion, the Skeleton Warrior, so it would make sense for the incense to be here. So it's actually providing that bonus. Now, since it's not there, what we need to do is come up with an algorithm to place it there. So there's a number of different ways of doing this. I had the AI recommend me some algorithms. And the one that I'm going to try to implement today is called simulated annealing, and I'll get into what that means in just a second here. Hello, OC. Good morning to you as well. Welcome back. Great to see you again. Okay, so based on what I've done in terms of like researching and also just asking the AI, this is kind of what simulated annealing does. So what you want to do is basically set up the grid in an initial placement. And then what will happen is you will create a new grid with some of the cards switched around. So you'll take an initial grid and you can set up the grid with an initial algorithm however you want. I'm probably just going to use random. And then you do a loop, and there's this temperature concept, which I will also go over in just a second. But you basically do a inside of a while loop, you generate a new grid. A neighbor grid is what this is being called. So it's just a comparison grid, basically. And then you swap or shift or move something on the neighbor grid. And then what you do is you score both grids based on some heuristic. So I'd have to write a heuristic. It'll be related to how many cards are actually being used effectively. And then it scores each grid, and it takes the higher score grid. And then it does the loop again and generates a neighbor for that grid. So the idea is that you're going to keep the annealing concept is that as this temperature cools down, you get closer and closer to a sensible grid that is relatively powerful. Or in the case of the general algorithm, you'll get closer to a grid result that you desire with this. So the temperature thing, I'm still trying to figure out exactly what this does, but basically you have a cooling off, so you have a temperature, and the higher the temperature is, the more the neighbor can vary. So basically, if you have a higher temperature, then that means that when you generate a neighbor grid, you do more changes to it. And if you have a cooler temperature, then you do slight or minimal changes to it. And the idea is that as the temperature cools down, you're approaching a more optimal grid, and so you want to make fewer radical changes to it. But you still want to have the potential for a change to make the grid stronger. So that's kind of the idea, because you don't want to have like you can imagine a situation where you're cooling down, and instead of reducing the chaos, the amount of randomness that happens as it cools down, you're keeping it the same. Well, you may get a board that's actually really good and then completely randomize it, and then for some reason that board also scores well, but maybe isn't as good as the first result or as desirable as the first result. So yeah, you just kind of want to cool down the rate of changes as as the temperature goes down. So that's the way I understand the algorithm based on what I've read here. And so I'm going to try to figure this out. And then we're going to see. So in here, this generate neighbors here. This is easy to do. This swap and shift is easy to do with uniformly sized cards, but I'm going to need to try to do this with cards that are of a different size. So I could have a 1x1 or a 2x2, all that stuff. And then we have an evaluation function, which that's the scoring that I'm talking about. Now, the one thing that I don't understand is that delta E, oh, the energy difference. New value minus current value. Delta E is greater than 0. Okay, so there are some things. So the reason I'm confused is because this AI output doesn't really do much with the temperature, but I was reading you can use the temperature to control the randomness to some extent. Oh, wait, here's the randomness. So the randomness is being controlled by the temperature here, but you can also make the temperature do other things as well. But we're going to start with the basic implementation here first. And I already have this enemy board optimizer here. So I'm just going to make use of this. And what I'm going to do is I'm going to create a public void simulated annealing. Okay. And we're going to take in a board inventory and a list of available cards. So just like this optimization here. So we want to create the initial placement on the grid. So what I'm going to do is private void create initial grid placement. Okay, so I'm just going to say for each var cell in board inventory, get all valid placement cells. Is that what I want? Cell and valid grid cells. Do I want to do sequential? Yeah, so get valid grid cells. What? Get all valid placement cells. Oh, I can call that with a card. Okay, I don't want to do that. Get valid grid cells. Public vector 2. I get valid grid cells ordered sequentially. Sweet. Okay, so that's just going to give us, because the valid grid cells here, I think, is a hash set. So that's not, I don't think hash sets have a guaranteed order. So I'm just applying an ordering to it so that we can, basically the sequential ordering goes by columns from left to right. So top, down, and then left, right. So I get valid cells ordered sequentially. And then what we're going to do is we're just going to try to place... Actually, you know what I'm going to need to do? Yeah, so I'm going to do this. For each... Actually... Yeah, I think I just need to iterate over all the cells again. So I'm going to have a nested loop in here, which is a little bit unfortunate, but we will store the ordered cells here. For something like a setup operation, I don't think a nested loop is a problem. So for each var card and available cards, then we're going to iterate over all of the cells, and then we're going to do board inventory.try place card at position, card cell, and then we can do an if in here. So this returns true if it's successful. Then we can break out of that loop and go on to the next card. Now the last thing that I want to do is var randomly sorted cards is equal to available cards dot. Is there a shuffle? Order by matthewtill.rng.randf. Okay, so we're just ordering those randomly, so that's a shuffle basically. And then we'll do randomly sorted cards. Okay, so now that we've got randomly sorted cards, we're just going to go through each cell, try to place the card at that cell, and then if that is successful, we'll just break out of it. And then we're going to need, actually, I think that's probably fine. I think that's probably fine. So let's do that. Create initial grid placement. Okay. Now let's just, I don't know, should I run it and see if that's, no, let's just keep going. So current value. So I need to do an evaluation of the grid state. So this is what's going to ultimately determine the scoring. So what I'm going to do is I am going to... Do I have an I scorable still? No. Okay. So what I'm going to do is I'm going to create... In my base card... Actually, let's go to this. Where is base card? Here. Actually, in ability. Data ability... where do I want to put this? I guess I'll just put it in here, whatever. Create new, no, actually I don't want to do that. Just do it through here. New file, I, ability, score. Space game.data.ability. Float, I think I can do, well, shoot. I'm probably going to need an execution context at the very least. Okay, in any case, what I'm going to do is I'm going to go to my base card here, and I'm just going to create a method to score all of the abilities. So let's do this. Public float score abilities execution context. Okay, what we're going to do is we're going to say return get all abilities.sum. Let's do .where. .where? .of type, yeah, I ability score, sum, score ability, execution context. So that's going to iterate over all of the abilities in the card and return the summed score. And then I can use that in my enemy board optimizer here. So that will be part of the evaluation function here. So basically we just sum up the score of all the cards. And you can also use like multiplication if there's a particularly strong link, which, you know, might be good, but we're just going to try this first. Okay. So is that what I wanted to do? I think what I want to do is, everything that implements iBoard queryable is going to be scoreable. So I'm not sure. So I might use this iAbility scorer here, but I think what I might also do is, maybe it's not a good idea to put this here. Yeah, maybe not. let me put this back. You know what? Let's start over here, and then I will add the ability score as necessary. So private void. I'm gonna do private float score card. I'm just gonna go one card at a time. I think this is gonna make more sense. So we're gonna pass in the card stats, card. Probably gonna need the board inventory component as well, but maybe not. Okay, so for each var, let's just collect up all the iQueryables. So var queryables is equal to card.baseCard.get all abilities of type iBoard queryable. And then let's do scorables. Okay, and then what we're essentially going to do is we're going to return that. And we're going to do with final filter here. And we need an execution context now. So let's go ahead and do this. I'm trying to do a normal tab, not a completion. Okay. Almost kind of wish I might have to change that keybind. Anyway. Var execution context is equal to make dummy execution context. That's going to fetch the player board and enemy board. I actually need to do this over again, so I'm just going to go ahead and grab this. This is going to be board inventory component.getTree. Board inventory component.getTree.getNodes and group. And then I need to replace that in the execution context. Source board, because the source board is the enemy board, so these are going to be actually reversed. Execution context.target board is equal to player board. Execution context source board inventory component is equal to board inventory component. What else do I need to put in here? What else do I need to put in here? Oh, target board. I've got those card stats turn executor component. Okay. Is that ever used? Hold on a second. Is it actually used in here? Add card. Oh yeah, it is used there. Okay, I think it's safe to leave that null in this context though. So I think this is fine. Oh goodness. I need to pass in the card stats now. Okay. So, let's see. Can you explain the process of making a game? Like, is there things to consider before starting? Well, that's the kind of beauty of doing anything software related is that you can freely make mistakes. Like, all the mistakes are undoable. I mean, unless you delete the production database. But when you're talking about just like, actually, that should be undoable too if you're running a proper operation. Anyway, the thing about doing like hobby projects for yourself is like, you can just go in and make a bunch of mistakes. You can go in and do a bunch of things that don't make sense or do a bunch of things unoptimally. And actually, that's probably one of the best ways to learn is that you create a spaghetti mess for yourself, but you get it to work. And then you say, okay, I can't maintain this spaghetti mess. So how can I approach it in the future? A similar problem in the future such that it's a little bit cleaner. So should you consider something? I mean, I think the main consideration would be like, the thing about if you're new to programming and you want to get into game development at the same time, that can be a little bit too steep of a hill to do at once because you're trying to learn how to make a game, like make visuals appear and do like the linear algebra that's required. But then you're also trying to learn programming, and trying to fit those two things together when you're brand new to it is a lot to try to figure out at once. So I guess the only consideration I would give to you maybe is, if you think that that's going to be too difficult, try to learn programming first. Try to get your an understanding of programming first before you go into game dev, so you're not trying to learn too much at once. But, you know, it all depends on how you are. It's possible to place the first card in a bad position where it can't be optimized by other cards. That is a good question. First card in a bad position where it can't be optimized by other cards. I don't think so. Because the way that the algorithm works is it chooses random cards to swap. So there's not like a targeted way that cards are swapped or moved around. So yeah. Okay, so this is scoring a card, and then it's just taking the length of the query board with final filter for any queryable, and then any scoreable, it's also scoring the ability. Okay, so. And we might not want to add these because, you know, it's a question of what happens if you implement iScoreable and query board at the same time. So this might need to be like an OR here, where we exclude any iBoard queryable that also is an iAbility scorer, but we'll worry about that later. Okay, so let's get to the meat of the algorithm here. So we've got an initial temperature, private const float initial temperature. I think these numbers are just arbitrary, so best grid, current grid copy. So instead of copying this board inventory component, because this is a node and everything, I think what I want to do instead is I'm going to create a method to get all card positions. I think this clear grid is a problem, but I think that's fine. So what I'm going to do is I'm going to return public dictionary vector2i card stats get board configuration, I guess. I'm just going to return cards on board to dictionary. Yeah. So this is just going to allow us to get the board configuration, basically just a dictionary of the card, each of the card's positions. But then I'm also going to want a void clear board, which, you know what? Let's see. Maybe this clear grid here. Maybe I'll use this instead. So let's see. Set board dimensions. This is a little bit dangerous to call, but we'll call clear board. Call it clear board. And then in here, this whole thing is just done. Is there... Oops. What is it? Remove... Try remove card. So I'm going to need to remove all the cards. So... So this try remove card should clear everything. The thing about removing cards from the grid is there's a lot that needs to happen. So it needs to unregister any signals that are registered with that card. And then it also needs to clear a bunch of the data. So I just need to make sure that whenever I'm clearing stuff, it's going through the same sort of removal function. So I don't end up with spaghetti issues down the line, state mismatches and whatnot. So recalculate board dimensions. I don't need to do this. I think what I can do is recalculate board dimensions in there. So the clear board is just going to do that. So the last thing that I want to do with respect to the board API, I guess you could call it, is public dictionary vector2i public void restore board configuration. We're going to clear board first and then place all the cards. So now I have an easy way of swapping in and out board configurations, and I can just store those as dictionaries. So Now that I have that, what I should be able to do is up in here, var temperature is equal to initial temperature, best grid, var best grid configuration is equal to get board configuration, best value is equal to current value. So var best score is equal to, I'll create a new, let's see. Yeah, let's create a new score board here. Private float score board. Do I already have that somewhere? No. Okay, so scoreboard board inventory, basically just gonna for each var card in board inventory component dot get cards on board ordered by priority. I don't think they need to be ordered by priority, but do I have a normal get cards on board? No. So we'll just use that. Then we're gonna say, actually, I think we can just do this. Return dot sum scorecard. Yeah. So we're just gonna sum up all the cards. Okay. So best score is equal to scoreboard. Perfect. All right. So now we got a temperature. Private const float min temperature. I don't know why these numbers are so... I'm just going to follow the example, but I don't know why these numbers are so weird. While temperature is greater than min temperature. And this is where we got to actually do the grid swapping around. Hello, Dragon Apple. Welcome back. Do you have a Discord server that I can ask about Godot? I don't have a Discord server yet. Not yet. And I am making a new game. Yes, indeed. Hello, Goramore. I bought your Godot 4 Survivors course tutorial last year and thoroughly enjoyed it. I'm a React developer, but lately in work I've been working on more of the backend C#. Seeing your lives recently has inspired me to pick up Unity with C#. I've started a cool little card game, so much fun. Well, I'm glad to hear that. I'm really happy, and I'm glad you enjoyed the courses, or the course. I do have a C# course in Godot if you're interested in that, but thank you for purchasing the Survivors one. And yeah, I'm having fun with this card game too. I don't know what it is. Like, there are different challenges. I usually make like action games, and so like there's a lot of things that I do in those kinds of games that are very samey, very similar. And this is a nice change of pace because I kind of like an asynchronous, like turn-based kind of thing. I guess it's not asynchronous, but there's a lot of asynchronous programming, like awaiting animations to finish and whatnot, and orchestrating the turns and all that stuff. It's a lot of fun. And of course, you got like the grid algorithms. Watch the start of the stream. The description is that you gave about simulated annealing is not the traditional way of implementing SA. Normally, the neighborhood is constant. Is that true? I have this other resource up that I was reading. Yeah, it looks like you're supposed to generate new, you generate a new board, but then you compare it to the one that you have currently. And you use a combination of probability and scoring. So like in here it says it keeps the old one proportional to how much better it is. Now it wants to repeat a few thousand times. I don't know if I'm going to do that, but of course help me and get my head around Godot fundamentals and how it works with game objects. So transferred well to Unity. Yeah, I do think that the skills overlap quite a bit. Temperature determines what changes you accept. Yeah, I'm going to implement that. Yeah, it is. Yeah, I'm having a lot of fun too with this. Yeah, I think we're on the same page. I think we're on the same page, Tommaso. Got both of your courses. Love the way you explain concepts and refactoring in the courses. I think a lot of devs struggle to refine and refactor, so it's great to see you work through it. Yeah, I appreciate that. Animated interests. Yeah, thank you. That was a big, that was actually a very conscious decision in the course, is like showing the process of refactoring. So the kind of secret is that I actually go in to those courses when I record them with like just a very basic idea of what the final game is going to look like, but I kind of just decide what lesson to do next based on like what the next sensible step is. And I think that leads to a really natural thing, because you kind of get into the rhythm of how do you actually build a game from the ground up, and like seeing how you go from like the first script and then, okay, what's the next thing that you tackle to like broaden the base of the game a little bit so you can add more stuff. And like it's this very natural like growing of the project, which I really like, and that is due largely to the exact lessons being unplanned. Like I just sit down and I say, okay, what's the next 15-minute chunk of work that can be done that makes sense here? And I think people enjoy that because it's much more organic, right? If the temperature's high, you allow yourselves to accept worsening solutions. Okay, I will keep that in mind. Currently working on a roguelite while watching your stream, kind of struggling with procedural room, generally like Binding of Isaac. Any tips? You know what? I wish I did. I wish I did have tips, but procedural generation is very, very difficult. I've tried it multiple times, and I just never... I don't know if there's something I'm not understanding about procedural generation, or I'm just not putting enough time into it, but I just never got procedural generation to work well. I think with Binding of Isaac it'd be easier because they're rectangular rooms. So what I would do for Binding of Isaac is I would just hand create several room configurations, like 20 or 25 room configurations, and then I would just choose randomly from those, and that would be like my procedural generation. But then you still need to think about like how do you place enemies in the room that are at the proper difficulty level and all that stuff, and that's just like, as far as I can tell, that's more of an art than a science. Like, and I think that's true of a lot of procedural generation. Like, a lot of it is just like make up a bunch of random magic numbers until the game feels the way you want it to feel, and that's the entire thing. Hello, Mikes. Is there a lady Firebelly? Well, I'm not married, but yes. Yes. Why? You trying to hit on me? I'm just kidding. We can definitely tell you put a lot of time and effort in these courses. You're welcome. Thank you. What determines temperature for this game, specifically damage, or how many attributes are? Well, the temperature is just it's an algorithm thing. It doesn't have any bearing over the gameplay. Something like wave function collapse. Yeah, wave function collapse is the one algorithm that I haven't looked into very hard because it seems very complicated, but people have said it's not that complicated. How did your dungeon system work in Gunforged? So I actually have a video on my channel called Dungeon Generation in Gunforged, and that was when I was still generating like actual levels for the game. And it's I don't know what the proper name of this algorithm is, but I called it the Tiny Keep algorithm because the developer of that game, Tiny Keep, posted a pretty detailed post on Reddit about how they accomplished that dungeon generation algorithm. And so I basically just followed that, and it turned out pretty good. It's still hard, but you know, the nice thing about that dungeon generation algorithm is you can pretty easily identify like important rooms, and then you can have like certain things spawn in those rooms and whatnot. I'd imagine some complicated algos to place stuff on the grid and choose random assets, would just do the multiple maps thing and randomly choose. Yeah, that's a good idea. Don't you think your GD chords needs an update? Yeah. Yes. I don't have enough time. I want to re-record the platformer course, and I want to re-record the Vampire Survivors course. Okay, so let's see if we can go in here. So generate neighbor. So what I need to do is best configuration is here. Generate neighbor. So this is the part. Let me just read a little bit further up along here. My cat is digging to the center of the earth through the litter box. It's very distracting. Very distracting. It's fine. It's fine. Okay, parallel tempering. What is that? Reheating. Yeah. Can you explain more about how temperature... So yeah, so this generate neighbor basically, it chooses a random, so I'll implement this at a basic level, but I do think that Tommaso is right, that I think that the moves that you can do or how much you can move should be dictated or influenced by the temperature. But let's go ahead and do this first. So generate neighbor, so move type. I'll just do this. mathutil.rng randi range. What do I want to do realistically? These are inclusive, so maybe we'll do, I mean, we don't have a rotate, so I basically just have two options here. Basically shift and swap. Choice equals 0. If choice equals 1. Okay, so the biggest problem here is going to be figuring out how to do this with the board. So generate neighbor configuration. So there's a little bit of a problem here, which is that I'm going to make a note of this. To do not all cards from available cards may be able to be placed. So I'm going to handle that. Generate neighbor configuration. So for a shift, essentially what I want to do is select random occupied position. So I want to select a random card and try to move it to the next available position. Or to a available position. So what I'll do is I'll do this. I think I can do this pretty easily. I just got to think about this carefully. So generate neighbor configuration. I think I should stop referencing the board inventory component. Oh wait, no, I need that. Okay. Okay. Let me think about this. Let's grab the cards on board. I think I'm going to need these anyway. So var cards is equal to board inventory component, get cards ordered by priority. Probably don't want to order these anymore when I'm doing all these loops, but we'll figure it out. Get cards on board ordered by priority. So if we want to do a shift, which is just a move, what I'm going to do is I'm going to choose a random card. No. There we go. Okay. So we're going to choose a random card. We're going to say board inventory component dot try remove card, random card. For each, var cell in get all valid placement cells for the random card. Then we want to order by random. If board inventory, I guess I don't, yeah, that's fine. Break. So this is just going to move it to a random position. That's basically all that does. And then let's go ahead and implement the swap as well. So we need to get 2 random cards. So var random card 2. I'll just do other random. I don't like putting numbers in my variable names for some reason. These could potentially be the same. These could potentially be the same card, but I'm not going to implement any logic to handle that. It's fine. If the card swaps with itself, it'll be fine. Okay, so what we're going to do is we're going to try removing that card, and we're going to try removing the other random card. Actually, we're going to need those positions. Var get cell, well, random card cell. Okay, we're going to remove both cards, and then we're going to say if board inventory component dot can place card at position. So if we can place the random card at the other card cell, and we can place the other random card. So if we can do both of those, then we're going to do that. Otherwise, we're going to put those things back where they were. Perfect. So the reason I need to do this is because the cards are different sizes. So it's possible that if you swap one card with another, that actually won't be a valid swap because of the size differential. So yeah, that's basically it. Good morning, Christopher. Hello, Luca. Welcome back. Good to see you both. Okay, so we've got swap and shift. So I think those are going to work. No, actually, this is going to be... Actually, this will be fine. Okay. All right. So now in this loop, this is going to be very inefficient, but I'm just going to do it inefficiently first, and then we'll see. New grid configuration is equal to, well, let's do this. I should have this return. Yeah, let's return dictionary vector2i card stats. Board inventory component.get board configuration. Okay, so now I can set this. Generate neighbor configuration with the board inventory component. We're going to score that board now. Calculate the energy difference. Okay. Okay, so let's do a delta E. So var delta score, new score minus best score, if delta score greater than 0. Basically what we're going to do is we're going to store the best grid configuration. Current grid equals, what is current grid? Wait, what is this doing in here? Oh, I see. We need to store a current grid. Okay. Var current grid configuration. We'll just do that, and then we'll set this equal to... I'm just going to do this twice so it creates new dictionaries. Okay. So we got current grid configuration, and we need a current score. These can be equal. I'm trying to wave function collapse room gen, and then we could all call it a roguelite, I guess. Yeah. SA is by its nature a very brute force solution. It will probably take a bit to run. Yeah, but I mean, my problem sets are not that big though, so I'm hoping that I can do it relatively quickly, but we'll see. Hello, Damien. Welcome back. So current grid configuration is equal to new.to dictionary. I'm just going to copy that. We don't want to store anything by reference here, I don't think. Actually, maybe it'll be fine. I don't think the new grid configuration gets referenced outside of that. So current grid configuration, current value is equal to new value. So current score is equal to new score. And then what I want to do in here is if the new score is greater than the best score equals new grid configuration, we want to break that reference. Okay. Probability is equal to what? Oh. Delta score divided by temperature, math-util, probability. Okay, so this is just going to generate a random probability here. New grid configuration. Yeah. Okay, that should be fine. The cooling schedule it has. Okay, let's just do private const float cooling rate. All right, we'll see. So in the while loop, temperature times equals cooling rate. Sweet. All right, well, let's go to the run manager then. And we'll just go ahead and do that. Let's see what happens. It's probably going to break, but we'll try it. Oh, wait, I'm actually not doing anything. Hold on a second. There's a couple of issues here. I need to set up the board with the best configuration, but I also need to update the board here. So what I'm going to do actually is, here's what I'm going to do. Board inventory dot restore board configuration, the current grid configuration. I need to restore that configuration, then generate the neighbor. Is this current score never used? What the heck? Is this current value never used? This best configuration. Oh, this needs to be if current score is greater than best score. Wait a second. If delta score greater than 0, New grid configuration, current score is equal to new score. Greater than best score. Yeah, this current score is never used anywhere. Okay. Not that I can tell anyway. Current value. Okay, well that seems useless. Anyway. Board inventory component or board inventory dot restore board configuration. Best grid configuration. Game looking good. Is it a backpack game? Yeah, kind of. It's like a grid inventory management game. Auto battler thing. But, yeah, it's... There are some things I'm going to do differently for sure. Well, I don't know. Let's see. See what happens. Ooh, so it placed that in the correct spot. Let's try it again. Nice. Sweet. Okay, so let's see. I'm going to actually increase the size of the enemy board. So run manager. Can I do that? Let's make it a no, 6 tall. Is that gonna work? Let me just make sure that'll work. I want to just put a bunch of cards in the enemy's capability here. Okay. So let's do this now. In the enemy here, let's do a... Do we want to do a voodoo doll? Let's do an axe. I want to see what an axe looks like. Axe. And let's do a scarab. And let's do an alembic. Okay, so the alembic is not going to do anything, but the scarab looks like it's going to work. Oh, wait. Did I do something? Oh, I accidentally undid this change. Oops. All right, let's see. Look at that. The alembic has been placed in the bottom left corner. The axe... So the only thing that would be more optimal here is if this... Oh, maybe it's not. Yeah, this could be a little bit more... I mean, I'm not expecting it to generate perfectly optimal things, but let's see. Like, this is not correct. I'll add some code to check on how many iterations. Yeah, that's not a good spot either. Let me check, let me add some code to check on how many iterations it went through based on the cooling rate here. Iteration. gd.print. $135 iterations. Honestly, that's pretty good. I mean, that's a really good placement, actually. The alembic is being maximized. The incense is affecting both minions. And the axe is aligned such that it's next to at least one minion. I'm going to get destroyed by this board. Look at this. Oh, wait. Oh, the axe counts as a ritual item, so the embalming fluid is generating shield for it. Wow. I'm going to see. Let's see if I can beat this board now. This is like the first glimpse of actual gameplay that I'm getting here. Okay, so what do we got? The axe is there. Okay, so those are going to be... So I'm going to need... Let's do a voodoo doll. Well, I've only got 3 slots. What is this game developer doing giving me only 3 slots? You kidding me? Oh, shoot. Maybe we'll do... This is not going to be enough damage, is it? Maybe we'll do this. I don't know if I can beat this board. Paralysis. Well, that will target a random minion. Oh, but it's got the lamb bone ring to its healing. Well, my board is so much smaller. This is unfair. All right, let's just see. No, I'm going to get destroyed. Oh my gosh. I got annihilated. I got annihilated. In Godot, do you need to worry about pointers? I mean, it depends. No, generally speaking, no. But if you are, for some reason, if you have a class, I don't know if you're working in C# whatever, but if you have a class that extends object, the thing about that is that that will not be garbage collected. So if you create a Godot object, even through C# script, that object remains in memory until you explicitly free it. So that's something that you have to keep in mind. Now, the way around that is to use ref counted to extend ref counted, which adds reference counting to the instance and will automatically be garbage collected. But there's a caveat with that too, which is that the Godot ref counting system doesn't handle automatically circular references. So if you create some ref counted objects that reference each other, they will never be freed until you manually free them or until you implement a workaround for the circular reference counting. So those are kind of like tangentially related to pointers, but you don't have to worry about like pointers like as you would in C++ or whatever. Yeah, same with nodes. So nodes are not ref counted. They don't extend ref counted. They extend Godot object ultimately. And that means that, yeah, if they're not in the scene tree and they're also no longer referenced anywhere by your script, then that's just memory that's being used that you can't free anymore. So there's a question like, what is, memory management versus like the actual technical pointer stuff. But anyway, I'm going to go ahead and get a drink. I'm out of coffee, so I'm going to go ahead and get that refilled. In the meantime, please check out the links in the description below. Those are all the ways that you can support my work. We're going to keep playing with this algorithm here. I have a couple of different things that I want to try still, but so far so good. So yeah, we'll continue on that for the next hour or so as soon as I get back. So BRB. Alrighty, I'm back. Sorry for the delay. Hello, Snupbill. Yummers. Welcome back to the stream. No worries at all. Thank you for being here. Welcome, welcome. What is the main reason for choosing C# rather than Unity or some other framework? I just like the Godot engine, honestly. I think it's the best 2D engine around. So that's the main reason. I like C# just because of the structure that I get from it. But yeah, my motivation was not to find an engine that works with C#. My motivation was just to find a good engine and then use whatever is available for scripting there. So I've used Unity a couple times. I just never really enjoyed working in Unity that much. And all I make is 2D games, and Godot has a bunch of out-of-the-box 2D functionality that's really great. So hello, Fiskits. Welcome back. Okay, so this is actually seeming pretty good. So there's actually, this is not the only problem that I have to solve. I also have to solve the problem of like, how do I choose the cards that are going to be placed on the board, you know? But anyway. So there's an issue here, which is that it may not have enough room for all the cards that are passed in. So what I'm going to do is I'm going to actually modify this to return the remaining cards. But first, I'm actually going to do this. Yeah, we can get rid of this. Get rid of that. I don't think I need this eye ability scorer just yet. Well, maybe I should put it in there. Okay. Work on simulated annealing. What's on the menu today? Today we're trying to implement an algorithm for placing cards on an AI grid, AI controlled grid. So that's what we're doing. We're using an algorithm called simulated annealing, which is working pretty good so far, but we're going to see. Anyway, create initial grid placement. So I'm going to return a list of remaining cards. Var, I'm going to do var remaining cards is equal to available cards.toHash set. Remaining cards.remove card. Remaining cards to list. And then in here, what I'm going to do is I'm going to say var remaining cards is equal to this for each var card and remaining cards card.queueFree. This queueFree is actually not a real thing. Basically, this card stats is ref counted, but it also has a reference to a card node, which contains a reference to the card stats. So I need to break that circular reference. So I break the circular reference here, and then I free the node, and then the garbage collection should kick in after that. So as long as I don't reference any of these cards after I call the simulated annealing, it should work. Okay. I'm going to read some about simulated annealing. Yeah, you should. It's an interesting idea. Will this have multiplayer capabilities? I think it was super auto pets that allowed you to fight other players layout. Yeah, I thought about doing something like that. I think that would be really fun, but it's just not in scope for now. I feel like that might be something I could add later pretty easily, since it's not like a synchronous multiplayer game. It'd be asynchronous, so it'd be a matter of sending player configurations to some kind of storage, like maybe like a NoSQL database or whatever, and then just, you know, when you're playing single player, on occasion pull from that database, you know, a similar player board and put it in the game. I think it'd be relatively simple to add that kind of online functionality if I wanted to in the future. So it's just not something I'm considering doing right now, but could add it in the future. Hello, Vishal. Welcome back. Alrighty, so this is actually feeling pretty good. Let me read what's going on over here. So I asked it. So yeah, I think this is where maybe I want to implement the iScoreable, where I want to give this some kind of multiplier. So in here, this optimized board is no longer used. I'm going to get rid of this. This is old stuff. Okay. So in here, this scorecard, it's just doing a straight linear addition. So it's just taking how many results are there from the query and then, you know, scoreable sum. So I currently have no scoreables. Also, this is just wrong. Oh, no, it's not. Never mind. Never mind. So scoreables, so that's good. So I'm kind of wondering if I should... Well, let me see. Let me just run this a couple times and see. Yeah, so this would be better if that was here. The problem is that, so this instance here is providing a score because it's an iQueryable, but the individual minions don't provide a score. So the problem is that I can't really say, hey, the scare would be better here because it's benefiting from the incense. Because that's not the way the relationship works. The incense finds the cards that it affects, so it has that information. But I need a way of knowing which card would be affected by that. So I think what I need to do is... Shoot. I can get a list of affected cells. Yeah, I actually don't know how I'm going to do this. I need a way of basically asking, hey, am I as a card being affected by any other card? How would I do that? I guess what I would do is I would iterate over all of the queryables, get all of the cells that they affect, yeah, I think that's what I'd have to do. So I'd have to iterate over all the queryables, get all of the affected cells, yeah, I think what I would do is I would move whatever card. Yeah, so I just need to add that extra step. So the card basically just needs to, once it gets moved or shifted or swapped, part of the score calculation is I actually need to iterate over all of the queryables and see for each queryable if that card is in the result set of the queryable. I think that's the way that I'm going to determine if a card is affected by that. So let's go ahead and add that to the scoring here. How long have you worked on this project? It's only been like 3 weeks, something like that. So simulated annealing is throwing a solution and then trying to solve if its randomness decrease. Kind of. It's, you basically, yes, you create a random board and then you create another board with something changed and you score both boards using some kind of heuristic. And then you say, okay, which board scored better? And then you keep that one. And then you just repeat that process. And the idea is that I'm not really making a whole lot of use of the temperature here. The only thing that the temperature affects is the probability of choosing a random board. So I have the current configuration and then I generate a new configuration. If the delta of the score between those things is greater than 0, then that new board is always taken. But if the score is worse than the current configuration, there's actually a probability that we'll take the worst board. So there's some randomness, and that's affected by the temperature. So I believe is this, as the temperature goes down, this probability also goes down? I think so. Yeah. So I think the probability is higher the higher the temperature is. So it's just, you know, it's kind of like just a brute force way of doing this. But you can make more use of the temperature, which I'm not yet doing, but I will probably do that. In any case, what I need to do is I need to see goodness gracious, where is the code? Am I missing something? Scoreboard. Yeah, scorecard. Here we go. So what I need to do is I need to say var affected by queryable sum is equal to query board with final filter dot contains card. Then we're going to add 1 or 0. Now I might actually want to change this actually. Let's make it 10. Length times 10. So we'll just make 10 the default kind of. So that way when I add I scorables, I can do something less than or equal to 10. You get a little bit of variation in there, I guess. Actually, I guess I could do the same thing with just like decimal values, so never mind. Let's do 1. So affected by queryable sum. So this is going to be affected by queryable sum plus wait a minute. This is wrong. Oh, wait, no, it's not. Oh no, hold on. I did this completely wrong. Did I do it the wrong? Wait a minute. Yeah, this is wrong here. This is looking at all the queryables on the card. Wait a minute, I'm getting confused here. No, this is not queryables. This is card queryable abilities. Okay. This needs to be based on the board inventory component. Is this? Let's see. Yeah. So I can do get cards on board ordered by priority of type I board queryable var all board queryables is equal to that. Okay. Then I can do all board queryables and sum up. So I'm going to execute all the queries on all of the board queryables and then see if it contains that card, and then I can say, okay, yeah. So for each queryable on the board that is affecting the current card, we'll add 1 to the score. So that should hopefully make it more reliable when a minion gets placed next to something that benefits the minion. That should make the score go up, which it wasn't happening before. So hopefully that works. Just train a model to do the board placement and use that in your app. I mean, one of these days that's going to be a relatively easy thing to do. How you feel your work velocity in relation to work without IA? What is IA? Am I missing? Oh, AI. Are you asking about AI? I feel much more productive using the AI tools, especially for doing rote work, like code that I already know how to write. I can just tell the AI how to write it, and it saves a bunch of time. It's less ideal for doing like broad, like overhauls and whatnot. But, you know. But I definitely think it's an improvement. Why a probability to take the worst board? Is it not your goal to make the score higher? Yeah, I mean that's just part of the algorithm. I don't really understand the entire theory behind it. That's wrong. Why did that generate like that? I don't really understand the entire theory behind it, but basically you want to, I think you just want to avoid getting into a locked situation where the board can't really change anymore because it's already like maximized or whatever. That's concerning. Why is that happening? I'm actually going to make this score 2 here. Make this times 2. I guess that doesn't really matter, actually. The axe is not placed in a good spot. That's a good position. The axe is not a good position. Okay, now the axe is in a good position. Still not optimal, but that's placed in a great position there. I don't think I want it to necessarily be optimal. I just want it to generally create good boards here. So let's see what the AI has written here. So this is basically everything that I've implemented so far. I should probably add some of this logging in here too. That'd be nice. Iterations, acceptance rate, improvements. So I might actually do that. Let's go ahead and add some of that logging in here. Accepted equals 0, var improvements equals 0. If delta E is greater than 0 or delta score, improvements plus plus. var is accepted false. I guess I don't need to do false. Or no, I do. False is accepted equals true. print stats everyone. I'm not doing 1,000 iterations. Should I? Let's see. Acceptances, improvements. Okay, let's just see what that does. What do you think about a starter in game development? Oh wait, I already answered that. Did you do the cover promo art for Gunforge yourself, or was that commissioned? That was commissioned, yeah. Also, why is the AI generated code in Python? Because I'm just in ask mode. I was just asking it for an algorithm to explain the algorithm. I'm not actually having it write code. So it accepted 95, acceptance rate. Okay, wonder what happens if I should time this too. Var start time is equal to os dot get time. What? msec. Do I have to do time dot? What is this? Yeah, time dot. Get ticks milliseconds. Oh, okay. Start time. Cool. Let's see what happens. So I'm going to increase this temperature to 500. Obviously, this is going to hitch the game if it runs too slow. 0.05 seconds. Interesting. But does that create a better board? It seems like it has very much created a better board, at least in that case. I'm still worried about that overlapping issue that I saw. I'm gonna have to figure that one out. So that works. That works. Oh, it didn't place the skeleton. Didn't have room for the skeleton? I might modify the algorithm too to try to slot in some of the cards that it couldn't slot in before. That's all right. So I think I could definitely make this faster. I'd have to probably create like a parallel board inventory system that's just not interfacing with like a Godot node at all. These are certainly decent solutions. I mean, decent solutions compared to if I just do this. Let's see. If I just have it create the initial grid placement, I think it's almost always going to be worse. So at least this algorithm is producing better than random. So like this, that I guess just by happenstance is good, but let's see. Isn't there a stopwatch in C#? Yeah, I just tend to use the Godot APIs. Hello, Neozoid, welcome back. How do you feel the release of Gunforge went? Was it around your expectations or did it underperform? I have a video on this very subject that I still need to edit, so watch the channel. But yeah, I would say that Gunforge was a moderate success for sure. The Alembic seems to be a challenge for it. I want to see why there was some overlap before. That was not good. Oh, here's a card that it didn't place. Actually, is this even working? Create initial grid placement. Ordered cells. Am I not using that anywhere? Get valid cells ordered sequentially. Maybe I don't want to do that. Let's do this. Actually, I'm going to need to do that here. That should actually create a more random grid to start. There we go. Hello, Polaris. Thank you. Hope you have a nice day as well. Yeah, so just by happenstance, it sometimes gets this right. Let me, I'm going to go to my run manager and increase the dimensions of the board a little bit more. Yeah, so here's a great example. So this is what a pure random board would look like. It's just completely nonsensical. That works, but then this is not, yeah, so now I'm going to turn the algorithm back on. And we're going to see how that works now. It's actually going to take longer now that the grid is longer or bigger. Oh no, I guess it didn't take that much longer. So what did it do here? Wow, it did not do a good job at all. What the heck? Oh, you know what? Actually, the random ordering of the cells probably is a bad idea, because then it's going to be space inefficient. It's not going to place as many cards on the board. Oh, that's an interesting problem. Okay. So yeah, the reason why I was doing it I guess actually that shouldn't matter, right? Actually, it shouldn't matter because it's getting all of the cells. It's just ordering them all randomly, but it's still iterating over all the cells and trying to place the card. So why is that being so space inefficient then? I don't understand. I don't understand. I don't think I need to do this, but... a lot of trickiness here. This doesn't make any sense. I think I'm going to need to turn the iterations up, but that means that I'm going to need to refactor a lot of my board code, which is fine, but I'm going to see what happens. Let's just turn it up to like 10,000, or no, 1,000. .08 seconds, acceptance rate 52%, optimized board in 180 iterations. Let's add another 0. It's getting worse. Why is the acceptance rate going up? I don't understand. I might add a scoring mechanism in here too for like, well, maybe not. Should it have such a high acceptance rate? Let's see here. Delta score. New score, best score. If delta score... I don't understand the point of this current score here. Unnecessary assignment of value. Why is that unnecessary? Why is that unnecessary? New score, scoreboard. Am I going crazy, or is this not actually a redundant, unnecessary assignment? Reload window. Sometimes the C#. If temperature very high, will accept most moves at the beginning. Yeah, I guess I don't know how the temperature is decaying here. So what I'll do is I will gd.print temperature. So you're adding a lot of iterations where it's accepting random moves. Yeah, I wonder if this probability is just not good. Should just change that probability. I'm trying to figure out why this current score... Why is this unnecessary? Delta score is greater than 0, else... It only gets set to the new score if the delta score is greater than 0, or if... I don't know. I don't know why that's happening. LSP out of whack. That's what I'm thinking, unless I'm just like not seeing that properly. So let's see. Temperature starts at 9,500, goes all the way down to here. So it's got a very high acceptance rate. So maybe that's the problem. So let's take a look at what the probability ends up being. It's possible that AI just gave me a bad probability thing, but let's see. All right. Yeah, so this is very high. So yeah, for most of the iterations, math delta score divided by temperature. So this is just like a random probability thing. Here is the example where the AI has doing different types of moves based on the temperature. So that's something that I want to implement as well. But temperature regions for complex... Ooh, temperature regions. Get move specific temperature. Scale temperature to problem. Probability delta divided by self. Yeah, so it looks like the scoring is just, this is just kind of like a random like magic number probability thing. So the probability starts very high and then gets very small. Probably not the best option for this. it is most, I would probably do random resets and not bother with the random acceptance rate at all. Essay is probably not the best option for this. I don't understand. It's not the best option. You would do random resets and not bother with random acceptance rate. What's the difference between a random reset and a random acceptance rate? So you would just not have this section here, this probability section. Random reset is you just restart the algorithm from the beginning. So you would run the algorithm for, you know, a handful of iterations or whatever, then run it again for a handful of iterations so that you're dealing with different starting conditions, and then just choose the best result from all of those different simulations. Only 2 boards were accepted? What? I'm actually going to modify this a little bit. 1.5. Stop a run for a few iterations without improvement. Gotcha. That's actually a pretty good one. Why is I have such a if I don't have the probability in place, if I don't have the probability in place, I get a very low acceptance rate. Only 4 improvements out of 225 iterations. Why is that happening? I would expect at least a little bit more iterations, or a little bit more improvement than that. I guess in just the vast majority of cases, the swap and shift doesn't work that well. Wonder if it would be fruitful to add just like a random reposition in here as well. I think the AI actually recommended that. Move specific temperature. Yeah, I'm gonna have to read through all this some more, but trying very bad moves. Well, how do I try? I mean, isn't that the point of the algorithm, to figure out what the good moves are? How do I make it so that it's doing better moves? Random repositioning is very unlikely to be improving. I guess I'm just not seeing the difference between starting the board from a random position and then randomly repositioning the cards. Like, one is better than the other, I guess because you're starting with a whole new state, but it's still random. I see. Normally you would try all the moves that exist from your current position. This is a lot more complicated here, this temperature manager. Setting the initial temperature. Yeah, I don't know. I'm gonna have to read through this and like really wrap my head around it. Is the algorithm factoring cards that need to be next to others? Yes. Yeah. Actually, those are the only type of cards that are scored right now. There is no, if you get a 0 score if you don't affect anything. Which maybe that is the problem. Maybe I should provide some level of scoring. I could score it based on maybe how space efficient it is or something. But I feel like I should be able to get pretty decent results with just what I've got here. Generate big move. Multi-phase annealing while running multiple phases with different temperature parameters. Interesting. Yeah, I'm gonna have to read through this code a little bit closer. But I think that's a good stopping point for today. I'll be spending my afternoon on this for sure. So yeah, if you want to support my work, please check out Gunforged. It's available on Steam now for $8.99 USD. It's linked as the first link in the description below. So this is the Steam page here. You can also purchase one of my Udemy courses on Steam if you're interested in learning how to build a complete game in the Godot engine. So yeah, I got quite an afternoon ahead of me, but we'll see how it goes. Hopefully by Monday I'll have something to show you all. But yeah, that's it for the streams this week. Thank you everyone for watching. Thank you all for being here. Thank you to the VOD watchers and lurkers as well. I know you're out there. And yeah, I'll see you Monday at 10 a.m. unless I do a surprise stream over the weekend. So if I do that, you'll be notified if you have the notification bells activated on YouTube. Okay, thanks again, everyone, and have a good weekend, and I will see you on Monday.